All right, guys. So here is just a different example. We're still in section 2.3 from our college algebra course. And let's take a look at number 12. I wanted to show you another example where what happens if, your graph was actually touching and not crossing the x-axis. How would you go about solving that? So again, you can see we have 1, 2, and 3 total hills and valleys, right? So remember that tells us that our equation is going to be of the form, and I'm again just going to use the notation given to us in the problem itself. So y equals x will be of the form a for your leading coefficient. And then since this is a 3 hills and valleys, remember that means it's going to be a 4th degree polynomial. So you should have 4 factors to represent each one of the roots, right, for the 4th degree polynomial. So I'm just using generic labels like M, N, P, and Q to represent the 4 factors of our 4th degree polynomial. So here, and again, just to refresh your memory, you can see there's 1, 2 valleys, and then there's 1 hill here, right? So that's a total of 3 hills and valleys. And that means the degree of your polynomial is going to be 1 more than the number of hills and valleys you have. So that's got to be 4. Because remember, the general rule of thumb is if you have the nth degree polynomial, then you will have n minus 1 hills and valleys, right? So since we have 3 hills and valleys, we know there's got to be 1 degree higher for the number, one number higher than the number of hills and valleys for your degree of the polynomial. So that's how we know we have a 4th degree polynomial. And that's why we need to have 4 factors in our form of the equation over here. So that's where these 4 factors of x minus m, x minus n, x minus p, and x minus q is coming from. All right, let's take a look at the x-intercepts next. So you can see we have x-intercepts at x minus 4. So again, guys, just to make sure we're kind of logging everything, we know this is a 4th degree polynomial. Our x-intercepts are going to be at x equals -4. We are going to have another x-intercept at x equals +1 and x equals +3. So you can see at x equals 1 and at x equals 3, our graph is actually crossing the x-axis. So that actually tells us both of those factors that are associated with those x-intercepts are going to have a multiplicity of an odd number. Or basically, you can say those factors will be raised to an odd exponent. Whereas when your graph touches but does not cross the x-axis, which is happening here, right? Because you can see your graph is not going to the other side of the x-axis. So since here my graph is touching and not crossing the x-axis, that tells us that this factor over here, right? The x minus 4, which is where this is happening, will have a multiplicity, which will be an even number. Whereas for these guys, the multiplicity will be an odd number. Okay, so since we know this is a 4th degree polynomial, that's actually pretty easy to break down then, because that actually tells us, and I know that just made it a little bit harder to read. So let me bring this guy back up just so we can read. So since we know that x minus 4 has to have a multiplicity, which is going to be an even number, that actually tells you the x minus 4 factor will have a multiplicity 2, which means it occurs twice. And then x equals 1 and x equals 3, which were the other 2 x-intercepts, will have a multiplicity of 1. And, of course, 1 is the odd number, which means they only occur 1 time. So you can see 1 plus 1 plus 2 adds up to 4, right? So those end up becoming our 4 factors. So when you write this down in our generic equation here, you will basically have, and again, we're not quite at the a value yet, so leave that as a as it is. So we know the factor x minus 4 has a multiplicity of 2. So that's actually going to be x minus -4. And you're going to have this repeating twice because of that multiplicity 2. Then your x equals 1 has a multiplicity of an odd number, which is 1 in this case. So that will be our next factor, x minus 1. And then the last one is going to be for the x equals 3, which also has a multiplicity 1. So it only occurs once. And that factor will be x minus 3. So you can see when we clean this up, again, leave that a as it is. Two negatives will become positive. So your x minus -4 ends up becoming x plus 4. Same thing, x minus -4 will become x plus 4. Then x minus 1 and x minus 3. Now, technically, if you wanted, you could write this as x plus 4 to the second power, x minus 1, x minus 3. And this is where you're able to see the multiplicity. So you can see this guy has multiplicity 2, this guy has multiplicity 1, this guy has multiplicity 1, which is what we basically came up with by looking at the graph, right? Alrighty, so now that we have the factors taken care of, we can now see how do we find the a value. And for that, we need to go back to our graph for a second. So let's make it larger, and you actually need to see where the y-intercept of your function is going to be. So you can see the graph is crossing the y-axis at this point here, right? So you can see this point here is going to have the ordered pair. And I'm just going to write that here. Your y-intercept is going to have the ordered pair 0 for the x value and +3 for the y value, right? So this is where your y-intercept is going to be at. So we need that because we will be using that to help us find the leading coefficient, the a value. Okay, so how do we do that? Once you have this generic form of your equation, you can go ahead and then plug in 3 for the y value and 0 for the x value in the equation and find out what the answer is going to be. So again, y value is 3. We're finding the a value. X is going to be 0, so that's 0 plus 4. That factor raised to the second power, 0 minus 1, 0 minus 3. Oh, and another thing I wanted to mention before we solve that equation is, let's make the graph bigger. You will see how the arms of your graph are headed upward. So we can say that the graph of the polynomial is opening upwards. So that actually tells you your leading coefficient a is going to be a positive number. So because the graph is opening upwards, a is going to be positive. If the graph was opening downwards, then your a value would have a negative in front of it. So the opening of the graph is also going to make a difference. So we don't really need to change anything since we know the graph is opening upwards, which means the sign in front of the a value is going to be positive. Alrighty, now that we have plugged in with our y-intercept of 0 and 3 into the equation, let's go ahead and simplify this. So we will have 3 on this side. 0 plus 4 is, of course, 4, and this is raised to the second power. 0 minus 1 is -1. 0 minus 3 is -3, right? Go ahead and multiply these numbers on the right-hand side. A will stay as it is. 4 squared, of course, is 16. And then you are doing 16 times -1, which is -16. And then -16 times -3. Of course, 2 negatives become positive. So 16 times 3 ends up becoming 48, right? So 4 times 4 will give us 16. 16 times -1 is -16. -16 times -3 will end up giving us positive 48. So at this point, you should have 3 equals 48 times a, right? So to get a by itself, we would go ahead and divide both sides by 48. And then let's see, 3 will go into 48 16 times, right? So 3 goes into itself once, 3 goes into 48 16 times. So you will actually see, once we simplify that fraction, that the a value comes out to be 1/16. right? And once you have that, you can go back and put it into our equation. It looks like I'm kind of running out of space here, so I apologize for this, guys, but I'm going to squish it down here. So your equation will actually end up becoming y of x equals, our a value was 1 over 16. And like I said, that will stay positive since the graph is opening upwards. And then our factors were x plus 4 repeated twice because it had the multiplicity of 2. And you can write it with the second power if you wanted to. Just write x plus 4 once and then put that whole parentheses to the second power if you wanted. Then you have x minus 1 and then x minus 3, right? So basically, all we really did was we took this form of the equation here. We already had the 4 factors, so all we had to do was plug in for the value of a. And as you can see, a came out to be 1 over 16. So you can type the answer in and check that, but I'll just show you, since I'm in teacher mode, I can show you the example or the solution. So you can see 1 over 16 for the a value, and that is a positive number. I can pull that down so you can see it a little bit better. So 1 over 16, and then x plus 4, x minus 3, x minus 1, and you can see that's what that equation comes out to be. So this was just to show you what happens if you do have an even multiplicity like this factor here did with the x plus 4, and how would that change when you are coming up with the equation of your polynomial. So again, guys, take a look at this. Let me know if you have any questions. All right, everyone, take care. Good luck.